Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In continuation of the previous video about the amazing properties of carbon nanotubes, now we are going to discuss about the challenges and the future outlook. So, what are the current challenges? See, we know that the carbon nanotubes are the amazing materials. Despite their amazing properties, carbon nanotubes face several key challenges that limit their widespread use related to production, performance, and also the safety. Manufacturing and scalability, the difficult and expensive in producing high quality carbon nanotubes. It is very expensive, and the CVD process, which is widely used, but result in a mixture of different types of carbon nanotubes. And next is about the purification and also the dispersion. Carbon nanotubes are often entangled in bundles and they contain impurities from the catalyst used in their synthesis. So this is a very major issue that it has been facing. It is becoming a major challenge for getting a highly purified carbon nanotubes. Performance transfer. The remarkable properties of the individual carbon nanotubes, like their immense strength and the excellent conductivity, don't translate perfectly to the larger macroscopic materials. That is, when they are used in bundles, in the fibers, or the composite materials. All these things, when these nanotubes are converted and used, they just don't transfer all the performance materials. And next is the health and the safety concern. So, toxicity, it's the ongoing research into the potential health impact from the inhalation or long term exposure is very crucial. So, carbon nanotubes are similar in shape and the size of the asbestos fibers. There is a lot of concern about their potential toxicity if they are inhaled. It's not good for the lungs. It causes inflammation in the lungs. Chirality control. It is difficult in reliably synthesizing the metallic versus the semiconducting carbon nanotubes for specific applications. Aggregating due to strong van der Waals forces makes uniform dispersion in matrices is very difficult. So, despite the challenges, the futures of the nanotubes is promising with anticipated breakthrough in synthesis, wider commercial adoption, and refined biomedical applications. So, what do we conclude from this? Conclusion: unlocking nanoscale potential. So, carbon nanotubes it poses an extraordinary combination of the properties that enable the transformative applications across the diverse field. So now a lot of research work is going on in the energy sector using the carbon nanotubes or the carbon materials. That is, while ongoing research and engineering efforts are addressing the current limitation, carbon nanotubes are poised to revolutionize the material science, electronics, and medicine, shaping the future of the technology and human health. So, if you're really interested in the carbon tubes or the carbon materials, just explore into the content of the buckyballs and the fullerenes. You it they are all the amazing materials in the nanoscale level of the carbon nanotubes, and you can find many informations from that. Thanks for watching.